Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. This second video lecture of week 6th is the continuation of my previous first video lecture of week 6th. In the first video lecture, we have discussed rules of differentiation for a function. And now today in this second video lecture, we are going to learn derivatives of trigonometric functions. Dear students, you know that there are 6 trigonometric functions like cos theta, sin theta, tangent theta, cotangent theta, secant theta and cosecant theta. Now here x is an angle for these trigonometric function, and we want to take the derivative of cos x with respect to x. So the derivative of cos x with respect to x is equal to minus sin x, and the derivative of sin x with respect to x is equal to cos x. Derivative of tangent x with respect to x is equal to secant square x, and derivative of cotangent x with respect to x is equal to minus cosecant square x, and derivative of secant x with respect to x is equal to secant x tangent x, and the derivative of cosecant x with respect to x is equal to minus cosecant x cotangent x. Now let's see how to prove these derivatives of trigonometric function. So first of all, I would like to explain the procedure for the proof of derivative of cos x with respect to x is equal to minus sin x. So dear student, you see over here, we know that in this proof the given function is equal to cos x, f of x is equal to cos x. So by using the definition of derivative, this is actually the definition of derivative of a function is equal to limit h tends to 0 f of x plus h minus f of x divided by h, where h is the delta x. Now we know that f of x is equal to cos x, so replace this x by x plus h. We find f of x plus h is equal to cos x plus h. So putting these two values, the value of f of x and the value of f of x plus h in this formula, you see over here the derivative of the function. Actually we want to prove that cos theta, derivative of cos theta with respect to theta is equal to minus sin theta. Now suppose f of x function is equal to cos x, so the derivative of the f function with this by using the definition of derivative, you see over here limit h tends to 0 f of x plus h minus f of x divided by h. Now putting these two values in this formula, the value of f of x plus h is equal to cos x plus h minus the value of f of x is cos x divided by h. Now this is actually a 0 by 0 undefined limit form. So we are going to define this undefined limit. So by using the formula cos a minus cos b is equal to minus 2 sin a plus b divided by 2 into sin a minus b divided by 2. This is the trigonometric identity. Now in this problem, this capital A represent x plus h, and the cos x represent b. So in this cos x plus h minus cos x will be equal to minus 2 sin x plus h x divided by 2 into sin x plus h minus x divided by 2. Now for this implication, you see over here derivative of the function is equal to limit h tends to 0 minus 2 by h. In the previous step, minus 2 by h. This 1 over h is actually represent in this formula cos x plus h minus cos x divided by h. So we can write 1 over h into. Now minus 2 by h, limit h tends to 0 minus 2 by h sin x plus x h by 2 sin this x plus x 2x 2 to cancel. So you see over here x plus h by 2 into sin h by 2 plus x minus x cancel. so sine h by 2. And in this expression, x plus x 2x, so 2x divided by 2, 2 to cancel, x plus h by 2. Now minus 2 as it is, and limit h tends to 0, sine x plus h by 2 as it is, and limit h sine by 2 divided by h. This is actually we shift this h to this term. So by using the formula sine theta tends to 0, sine theta by theta is equal to 1. We have already discussed this formula in the previous video lecture. Now minus limit h tends to 0, sine x plus h by 2, limit h tends to 0. Now shift this minus 2 to this term, to this expression. We can write limit h tends to 0, sine h by 2 divided by h by 2. Now using this limit formula, this is the theorem, limit theta tends to 0, sine theta divided by theta is equal to 1. So you dear student, you see over here for this expression, putting limit h tends to 0, sine h by 2 divided by h by 2, this limit actually equal to 1, you see over here. And now derivative of the function is equal to minus, putting limit h to 0 in this expression, h by 2 mean 0 by 2, minus sine x plus 0 by 2 dot 1. This limit is equal to 1. Now this implies that derivative of the function is equal to minus sine x. So the derivative of the cos x with respect to x is equal to minus sine x. Now another proof, for example, derivative of tangent x with respect to x is equal to secant square x. Dear students, for the derivative of sine x is equal to cos x, you see here in the previous slide that derivative of cos x is equal to minus sine x, and the derivative of sine x is equal to cos x. So you see over here, this is actually the proof for the first formula. And now try yourself to prove this second formula, derivative of sine x is equal to cos x, by using this definition procedure. Now we are going to prove derivative of tangent x with respect to x is equal to secant square x. So the derivative of tangent theta with respect to theta is equal to secant square x. Now how to prove? By using the definition of derivative, f dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. Putting the value, now let's see, tangent x is equal to f of x. So f of x is equal to tangent x, and f of x plus h is equal to tangent x plus h. Now putting these two values in their definition, derivative of the function will be equal to limit h tends to 0, f of x plus h is equal to tangent x plus h minus f of x is equal to tangent x divided by h. Now we know that tangent theta is equal to sine theta by cos theta. So tangent x by h is equal to sine x by h divided by cos x by h, and tangent x is equal to sine x minus cos sine x divided by cos x. Now taking the LCM by cross multiplication, you see over here, multiplied this expression to this, and sine x multiplied with the cos x plus h, and multiplied the denominator. This is the easiest process for the LCM. Now we know that sine alpha plus beta minus cos alpha plus beta, and you see over here sine alpha minus beta is equal to sine alpha sine alpha cos beta minus cos alpha sine beta. Now in this expression, actually x plus h represent alpha and x represent beta. So sine alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. The right hand side of the formula, you see over here, this is the right hand side of the formula, sine alpha cos beta sine alpha, you see over here, sine alpha cos beta minus cos alpha sine beta. So x plus h is represent alpha and x represent beta. So sine alpha minus beta is equal to, now derivative of the function is equal to limit h tends to 0, sine x plus h minus beta, sine x plus h minus x, using this formula. Now x and minus x cancel, and we write limit h tends to 0, sine h divided by h into cos x plus h. Now limit h tends to 0, sine h by h, we can write this theorem is equal to 1, and limit h tends to 0, 1 over cos x plus h. Now putting the limit, this theorem will be equal to 1, and 1 over cos x into cos x plus 0. So cos x and cos x is equal to cos square. 1 over cos square is equal to secant square. So the derivative of tangent x is equal to secant square x. Now another proof, derivative of secant x with respect to x is equal to secant x tangent x. Now dear students, try yourself for the derivative of cotangent. Derivative of cotangent is equal to minus cosecant square x, and now the derivative, we are going to prove this derivative of secant theta with respect to theta is equal to secant x tangent x. Now by definition of derivative, f dash with respect to x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. Now suppose secant x is equal to f of x is equal to secant x, then f of x plus h is equal to secant x plus h. Putting these two values in this definition formula, you see over here, derivative of the function is equal to limit h tends to 0, secant x plus h minus secant x divided by h. Now 1 over cos is equal to secant x, so secant x is equal to 1 over cos x. Now 1 over cos x plus h minus 1 over cos, and divided by h can be written as 1 over h. Now derivative of the function is equal to limit h tends to 0, 1 over h into, taking the LCM, cross multiplication, and multiplied the denominator, cos x minus cos x plus h divided by cos x plus h into cos x. Now again using the formula cos alpha minus cos beta, or we can say that cos a minus cos b is equal to minus 2 sine a plus b divided by 2, and sine a minus b divided by 2. So in this expression you see over here, cos a minus cos b, a represent x and b represent x plus h. Now using this formula, limit h tends to 0, 1 over h cos x into cos x plus h as it is, and for the denominator we use the formula minus 2 sine a plus b divided by 2 and sine a minus b divided by 2. So a represent x and b represent x plus h. In the given expression you see over here, a represent x and b represent x plus h. So now by simplification, limit h is 0, x plus x, 2x divided by 2 to cancel, so x plus h by 2, and minus x plus x cancel, sine into minus h by 2. Now limit h tends to 0, minus 2 divided by h, and sine x plus sine x plus h by 2 into sine into minus h by 2. Minus h by 2 is the angle. So now limit h tends to 0, 1 over cos into cos x plus h as it is. Now dear students, we know that sine into minus theta is equal to minus sine theta. So this expression, this term will be written as, we can write this term as sine into minus h by 2 is equal to minus sine h by 2. So minus and minus plus, so 2 into limit h tends to 0, sine into x plus h by 2, and limit h tends to 0, sine h by 2 divided by h, and 1 over cos x into cos x. Putting the limit for this term, h is 0, so 1 over cos dot cos, and now shift this to this denominator for the theorem, limit theta tends to 0, sine theta by theta. So 1 over cos into cos x as it is, and putting this limit in this expression, sine x plus 0 by 2, and limit h tends to 0, sine h by 2 divided by h by 2, this limit will be equal to 1. Now you see over here the derivative of the function is equal to sine x divided by cos x into cos x. So sine 1 over cos, we can write 1 over cos into sine by cos, and 1 over cos is actually equal to secant theta, and sine by cos is equal to tangent theta. So the derivative of secant theta is equal to secant theta dot tangent theta. Now dear student, try yourself for the proof of derivative of cosecant theta. Derivative of cosecant theta is equal to minus cosecant cotangent theta. Now some problem for practice, how to differentiate this function y is equal to x square dot cotangent x minus 1 over x square. So dear student, you see over here these two functions are in the product form. First of all, using the product rule for the derivative of x square dot cotangent x, so taking the derivative of the function with respect to x, so derivative of x square into cotangent x with respect to x minus derivative of 1 over x square, and we can write 1 over x square is x power minus 2. Now using the power rule for this term, x square is a first function and cotangent x is a second function. So first into derivative of second function plus second function is it is, and the derivative of first function minus, now using the power rule for this term, minus 2 multiplied with the coefficient and subtract minus 1 from the power, we obtain x square into the derivative of cotangent is equal to minus cosecant square x plus cotangent x, and the derivative of x square 2x, and using the power rule for this term we obtain minus 2 into x power minus 3. So this is the derivative of the given function. Now after simplification we obtain derivative of the function with respect to x is equal to minus x square cosecant square x plus 2x cotangent x plus 2x power minus 3. Now another problem, to take the derivative of the function y is equal to cos x divided by 1 plus sin x. Now using the quotient rule, because these two functions are in the quotient form, 1 plus sin x is a first function and cos x is a second function. So by quotient rule we know that first function is it is, and take the derivative of second function minus second function is it is into derivative of the first function divided by square of the denominator, square of the first function. Now take the derivative of cos. In the formula we know that derivative of cos minus sin x and derivative of cos derivative of sin cos x. So 1 plus sin x into minus sin x minus cos into the derivative of 1 is 0 and the derivative of sin is cos x divided by 1 plus sin x whole square. Now by simplification we obtain derivative of the function with respect to x is equal to minus sin x minus sin square x minus cos square x divided by 1 plus sin x whole square. Now taking common minus from these three terms, we obtain minus into sin x plus sin square x plus cos square x divided by 1 plus sin x whole square. So sin square plus cos square is equal to 1. Now derivative of the function is equal to minus into sin square plus cos square is equal to 1, and this sin x is it is divided by 1 plus sin x whole square. Now 1 plus sin x and 1 plus sin x cancel, and this implies that the derivative of the given function is equal to minus 1 over 1 plus sin x. Now dear students, another problem, to take the derivative of the function y is equal to x divided by cos x plus cos x divided by x. With respect to x, we want a derivative of this function. Now dear students, in this first term there is quotient rule, in the second function there is also quotient rule. Now first of all, the first term derivative, taking the derivative of the problem with respect to x, we know that derivative of x by cos x plus derivative of cos x by x. Now for quotient rule for the first term, first function derivative of second function minus second function as it is, and derivative of first function divided by square of the denominator, plus now quotient rule for the second term. In the second function, in the second term, x is a first function, so first function derivative of second function minus second function as it is, and derivative of first function divided by square of the denominator. Now the derivative of x is 1, and the derivative of cos minus sine x, and in this expression derivative of cos minus sine and derivative of x is 1. So you see over here cos x into 1 minus x into minus sine x plus x into minus sine x minus cos x into 1. So this expression divided by cos square and this expression divided by x square. Now cos x plus x into sine x divided by cos square plus minus x into sine x minus cos x divided by x square. So this is the result of the derivative of the problem. Now another problem, y is equal to x square dot cos x minus 2x sine x minus 2 cos x. So the derivative of this function with respect to x will be equal to dy by dx is equal to derivative of the given function. You see over here. So the derivative of this term, we use the derivative of this function. For the derivative of this function, we use product rule, and in these two terms also in the product form. So the derivative of these two functions will be by product rule, and the derivative of cos is equal to minus sine x. Now you see over here x square is a first function and cos x is a second function. Similarly in this function, in this term, x is the first function and sine x is the second function. So applying the product rule, first function derivative of second function plus second function derivative of first function. Now for the second term, for this second term, minus 2 into x is a first function as it is, and derivative of second function plus sine x into derivative of first function plus derivative of cos. You see over here in this term derivative of cos x minus sine, so minus or minus plus, minus and minus plus. Now derivative of the function with respect to x square is it is, derivative of cos minus sine plus cos x is it is, and derivative of x square 2x minus 2 into x is it is, derivative of sine cos x plus sine x, derivative of x is 1 plus 2 sine x. Now after simplification we obtain dy by dx is equal to minus x square sine x plus 2x cos x minus 2x cos x minus 2 sine x plus 2 sine x minus 2 sine x and plus 2 sine x cancel. Similarly minus 2 cos x and plus 2 cos x cancel. So we obtain the derivative of the function is equal to minus x square sine x. Now dear students, the conclusion of this lecture, note that the conclusion of this lecture. In this lecture we have discussed the derivative of the trigonometric functions. For the derivative of trigonometric function, these 6 formulas are very important. So dear student, note that derivative of cos with respect to theta is equal to minus sine theta, and derivative of sine theta with respect to theta cos theta. Derivative of tangent theta with respect to theta is equal to secant square theta. Actually in this presentation x is an angle, so the derivative of cos theta with respect to theta, so x is a theta. Now derivative of cos theta with respect to theta, derivative of cos x with respect to x will be equal to minus sine x, and derivative of sine x with respect to x is equal to cos x. Derivative of tangent x with respect to x is equal to secant square x. Derivative of cotangent x with respect to x is equal to minus cosecant square x, and derivative of secant x with respect to x is equal to secant x tangent x. Similarly derivative of cosecant x with respect to x is equal to minus cosecant x cotangent x. So dear student, in this lecture I have already proved these 3 trigonometric formulas, the proof of cos theta, the proof of the derivative of the cos theta, and the proof of the derivative of tangent theta, and the proof of the derivative of secant theta with respect to theta is equal to secant x tangent x. So you all try your best to prove that derivative of sine theta is equal to cos theta. So derivative of cotangent theta is equal to minus cosecant square theta, and derivative of cosecant theta with respect to theta is equal to minus cosecant theta cotangent theta. So this is the home task for you, that how to prove formula number 2, formula number 4 and formula number 6. And you see over here we have discussed some problem by using these formulas. Actually in the problem you see over here, sometime we obtain the derivative of two functions when two functions are in multiplied form, the derivative of two functions when two functions are in the quotient form. So first of all, applying the rule, and in the rule we know that after applying the rule, the derivative of first function are the derivative of the second function. First function is it is, and into derivative of second function, plus second function is it is the derivative of first function. This is actually the product rule. You see over here in this problem there is the product rule, x square into cotangent x. So first of all, apply the power rule or product rule or quotient rule, and then take the derivative of the specific term. So dear students, first of all, note the derivative for trigonometric functions, formula of derivatives of trigonometric functions, and rules of differentiations. Now this is the end of this segment. Thank you. Allah Hafiz.